Hello everyone, welcome back. Today we are going to learn about a topic that is crucial for making computers work efficiently. As we all know that the main function of any operating system is used to make the computer work efficiently. So today we will be learning about CPU scheduling. So, have you ever wondered how your computer decides which task to execute first and when to execute the next file? So, when you open multiple applications, that's where CPU scheduling comes into play. In this video, we will be covering what CPU scheduling is and why it is important. Then we will learn about the key scheduling concepts. After that, we will be learning about performance criteria that is used to evaluate the scheduling algorithm. So, without wasting any more time, let us move on to our first topic, that is CPU scheduling. So, in the CPU, that is Center Processing Unit, is the brain of the computer, but it can only execute one process at a time on a single core system. It means that if it is executing a single program, then it cannot open or execute any other program. And since modern computers run multiple applications at once, the OS decides which process gets CPU time and for how long. This decision making process is called CPU scheduling. So, why is CPU scheduling important? Why do we have to study that? The first one is it ensures effective CPU utilization. Then it also provides fairness by giving each process a chance to execute. It always provides a fair chance to every process. Remember this. Then it also improves the system responsiveness. Since the priority of each task is already set, then the system will be more responsive. After that, it also helps in multitasking and time sharing. Let me you an example. When you are streaming a video on Netflix or while browsing the web or downloading a file from the internet, CPU scheduling ensures that all the tasks run smoothly without freezing your system, right? Okay, now let us move to some key scheduling concepts. The first one is burst time, that is also known as execution time. It is the time required by a process to complete execution in the CPU. Some processes may have short execution time or some have long execution time. That is, the short burst times are a calculator operator. In the calculator operation, a short time is needed. But in the video rendering, when we are editing a video, we require for it for a long time. So the burst time will be greater. Then we have the arrival time. Arrival time is the time when the process enters the system and is ready to execute. The scheduler decides which process to pick first based on its arrival time. So it is very important. Then we have the CPU cycle. It is a process which alternates between the CPU execution and IO operation. Some processes are CPU bound, more CPU usage. It means that if the process is a CPU bound, it will use more CPU, while others are IO bound. It means that they will be waiting for the input or output. After that, we have preemptive and non-preemptive scheduling. This is a very important concept in scheduling. So, preemptive means that the CPU can be taken away from a process if a higher priority process arrives. Preempt. It means that we can preempt the process. Okay. It means that if a process is going on, but a higher priority process arrives and it needs execution immediately, then the CPU will be taken away from that process and will be assigned to that higher priority process. Then we have non-preemptive. It means that we cannot preempt that process. If a process is going on and is having the CPU, then it will run until it finishes or switches to input or output. Let me give you an example. In a hospital, a doctor might interrupt a normal patient checkup to attend to an emergency case. This is preemptive scheduling because the emergency case needs immediate attention. But if the doctor completes each checkup before moving to next, that's non-preemptive scheduling. Okay. Then we have dispatcher. Dispatcher means that it manages the CPU and control between the processes. It ensures that the fast and smooth transition between all the processes that are in place. Then we have context switching. Context switching means it is the process of saving and loading process states when switching between tasks. The frequent context switching slows down system performance. This is an con of context switching that it slows down the system performance too. Think of it like switching between multiple browser tabs. Too many tabs can slow down your system. So it is always advisable that you close your tabs that are not in use. Now, we will be moving on to performance criteria. Okay, performance criteria means the criteria on which we can judge the performance of that scheduling algorithm. Wait, it means that to know whether a scheduling algorithm is good or bad. So we have certain performance criteria. The first one is CPU utilization. It means that the percentage of time the CPU is actively working. It is not idle. If it is working, then it is the CPU utilization. Higher CPU utilization equal to better efficiency. For example, if your CPU is busy 90% of the time and idle 10% of its time, then the utilization is 90%. The goal is to maximize CPU utilization, that is, to keep it busy but not overload. Then we have throughput. It means the process per second. The number of process completed per unit time is called throughput. Higher throughput equal to better system performances. We always need to have a better throughput if our system is going to be better and better. A system that processes 50 tasks per second has better throughput than one that processes 30 tasks per second. Obviously, if someone is capable of doing 50 tasks in just a second, it is more better and performance oriented than that one which can complete only 30 tasks per second. The goal of throughput is to maximize the throughput. Then we have turnaround time. It is a time that is taken from process arrival to completion. And the formula for this is turnaround time equal to completion time minus arrival time. One example is a process may arrive at 10 a.m. and finishes at 10:05. 10:05. Now, you will be telling me in the comments what will be the turnaround time of this example, and the goal is obviously to minimize the turnaround time so the efficiency is better. After that, there is waiting time. It is the time that a process spends waiting in the queue before execution. Waiting time equal to turnaround time minus execution time. Let me give you an example. A process waits 3 minutes before execution and takes 5 minutes to complete. Then the waiting time is 3 minutes. Okay. The goal is to minimize the waiting time and avoid any system lag that is going to occur. After that, last we have response time. Response time is the time to start execution. The time from process arrival to when it starts execution. It is important for interactive systems that we learned about in the previous lectures that is used in the user interface. For example, if you click on a video editor and it starts loading after 2 seconds, then the response time of that task is 2 seconds. The goal of this is to minimize response time for better user experience. Now, moving further, let us see what we have learned in today's lecture. Firstly, we have learned that CPU scheduling. CPU scheduling decides which process gets CPU time to ensure efficient multitasking. Then we learned about key scheduling concepts including burst time or execution time, the arrival time, CPU cycle, and context switching. After that, we learned the performance criteria for deciding which scheduling algorithm is good or bad. First one, CPU utilization. It should be maximized or always. Then throughput. It should always also be maximized. Then turnaround time. So it will be also maximized. No, it should be minimum. The turnaround time should be minimum along with the waiting time and response time. So I hope this video was able to help you all. I appreciate how computers can run multiple tasks efficiently, and this is the task of CPU scheduling. If you found this video helpful, don't forget to like, subscribe, and comment below. See you in the next one. Thank you.